In this movie, I'm going to explain the purpose of class diagrams. Why would you produce class diagrams in a project? In summary, the reasons would be to model the concepts that are used in the business and the language they use to refer to them, to analyse use cases and identify the classes required to implement each use case, to model the overall structure of the system in terms of the classes and interfaces and their relationships, to reason about the system and make design decisions about how it will work, and to provide the basis for implementation. Let's briefly look at each of these in turn. Class diagrams help us to document the concepts that are relevant to the business that we're working in. People often talk about the business domain, the problem domain, or the solution domain, where the term domain is used to put a boundary around the topics of interest. As a business domain, it can be very broad, like the domain financial services, or it can be narrow, like the domain of automating domestic devices. A class diagram, or a set of class diagrams, can be used to document the things and concepts that are relevant to the domain. This helps communicate with the stakeholders for the system, and can help resolve problems where the same word means different things to different people, or different people use different terms to describe the same thing. We call this a domain model. A common use of class diagrams in the early stages of a project is to model the classes that collaborate to deliver the functionality of a particular use case. These will usually include classes from the domain model, together with classes that manage interaction with the user and display of a user interface. The class diagrams from a set of use cases can be used to build up a picture of all the required classes. This approach is known as robustness analysis. Class diagrams enable us to model the overall structure of the system in terms of classes, interfaces, and the relationships between them. If we have a domain model for a broad business domain, these diagrams may focus on a specific system area within that domain. We may also group classes into packages based on their role in the system, or to group related classes together. Class diagrams allow us to reason about the problem and its solution. There may be more than one possible solution that will meet the stakeholders' requirements for the system. We can model these different solutions and think through the implications. Different possible solutions may all meet the functional requirements, but have different impacts on non-functional requirements or qualities of the system, such as performance or its future extensibility or maintainability. We can work through these implications without having to actually build the system. When we come to implement the system, the class diagrams form the basis for the implementation in a programming language, whether it's Java, as in this slide, or C# or Python or something else. Some modelling tools allow us to generate program code from the model, and some use model-driven architecture, which allows us to take a logical, platform-independent model and generate different platform-specific models for different languages, and then generate code. The most sophisticated allow developers to edit the code in an IDE, and then synchronize the changes back into the model, an approach known as round-trip engineering. So, in this movie, we've briefly looked at the reasons for producing class diagrams, from analysis through design to implementation.